Good afternoon, everyone. I'm Steffen Grunwald. I'm Solutions Architect at AWS, and my job is to help customers to build sustainable architectures on AWS. This is SUS302, Sustainable Architecture, Past, Present, and Future. And originally, we planned this title to be a Sustainability Carol, but we've been asked to stop. We've been asked to stop this, so instead we are having this title. Good news for you is nobody in this session will sing. What I will do instead is to talk about the motivation of application teams in the past to drive resource efficiency in architectures. And then the second part, I'll talk about what we observe today at customers who run sustainable architecture, sustainable workloads, and at a broader scope, sustainable IT departments. And after that, I will share what we expect in the future to change on customer side and on AWS side to be more successful in achieving our goals. The goal for this session here is that you will leave this session, preferably at the end, with an idea of how you can find things you can optimize and how you can improve it. Optimization for resource efficiency is nothing new. I think it's safe to say that architects and developers and you are celebrating optimizing response time, shaving off a few seconds of a response time of the build process, of the deployment process. So that is nothing new. So I looked at my own bookshelf in preparation for this talk here, and I found this book as an example for Java and how you can optimize. More than 400 pages. It contained general applicable rules for performance management. It was about creating a plan, this measure, test, optimize, learn, and then repeat that in a loop. It was mainly and very specific of that 500 pages or 400 pages, specific to the implementation of the application. So mostly about, should I use an array, should I use a vector, how should I deal with strings, etc., rather than looking at the overall architectural changes of the full stack. So it was just a small portion. And this was the focus of this book, because the audience asked for it. They had an initial budget, and they had an initial static boundary set by the infrastructure, and everything they built needed to fit into this box or these boxes. So when developers were facing performance issues, it was a very difficult process, sometimes even unknown process, to increase this box, to increase the static boundary. Instead, it was very easy, or more easy, to change the application to fit into this boundary and to solve these problems this way. So the application often needed much less resources than this static boundary, but it must never use more. And this was changing around 2006 when AWS announced Amazon EC2. Here in Jeff Barr's blog post, where the density of features was not as high as today, so there could still sneak some travel reviews into that blog, as you can see. EC2 was the response to that static boundary, to that static infrastructure. Customers could scale it out as needed for peak use, and then scale it down again as not needed. And using economies of scale, EC2 has always been highly efficient multi-tenant infrastructure compared to the on-premise data center single-tenant equivalents. So, and because the Amazon EC2 was so efficient in the operation, it was so easy to scale out, also a rebound effect kicked in, and it became a popular choice to use more of that efficient infrastructure. And at this point, imagine you've been a developer and you've been tasked to speed up the application. You had two choices. Either you could read that book, that 400 pages, make that change in the application, maybe introduce regression in your application, or just tune the application or give the application more vCPUs, more boxes in a horizontal cluster to make it faster. And because, don't get me wrong, it's okay to use more resources as long as your business is asking for that. So as long as the demand of your customers grow. More than a decade ago, Werner already advocated for cost-aware architecture to track and model cost efficiency. It was a call to use the elasticity of the cloud, and as you grow your infrastructure, also use and leverage economies of scale to increase the efficiency. And in the same year, also, the well-architected pillar was launched with plenty of ideas in the pillars there with best practices, for example, around cost and performance to tune these applications. I cannot put a concrete date to this, but the raising awareness to the effects of human-made climate change also raised the awareness of stakeholders of an organization to become more sustainable. Customers made sustainability goals as a decision criteria to decide where they want to buy from. Other stakeholders made it key to the question whom they want to work for, what the rules of the market are, and whom they want to work with, and what to invest in. So companies communicated their goals in public pledges like the Climate Pledge. Amazon has been a founding member of this in 2019, but today it has over 400 signatories. Its goals are, or the pledge is, to become net zero carbon by 2040, 10 years ahead of the Paris Agreement. And when companies are setting these goals to becoming net zero carbon, this includes the whole company. It's not only a single department, but it also includes IT. And that also became a driver to optimize, not just for cost or for convenience of your users, of your customers, but also for the environmental impact. And more awareness to sustainability and decarbonization also picked up another idea that is already more than 20 years old, and that is the Greenhouse Gas Protocol. It defines a way to quantify carbon emissions in 3 different scopes, and I want to shortly introduce you to these 3 scopes. Scope 1 is direct emissions. It's burning fuel, wood, anything which burns or emits greenhouse gases. And in IT, that could be a diesel generator, which is used when the grid is not available. And the emissions from that burning contribute to Scope 1. Scope 2 is emissions from purchased energy. Steam, heat, cooling. In IT, that is electricity coming from the grid, and its carbon contributes to Scope 2. And Scope 3 is everything else. It's indirect emissions up and downstream in the supply chain. The emissions depend a lot on what products you're creating and providing, how your supply chain looks like. And in IT, that is, for example, equipment that is delivered to the facilities, to the data centers, like racks and servers, and that could also be the building itself. And the carbon emitted for this is contributing to Scope 3. And the practice of carbon accounting is creating the sum of all these, building a complete picture of an organization, and also find a way to allocate this to different teams and to different products. And each team can influence then the carbon, or should own and influence the emissions that are related to the value they bring. And that could be a shop floor in manufacturing, or that could be an IT application. And here I want to come back to IT architectures. I met some application teams in well-architected reviews, for example, that prioritized cost very low, optimization for cost very low, if they deliver for scalability, if they deliver for customer experience, etc. So with a raised attention to sustainability, these optimized pledges, IT in all businesses faced a new pressure for sustainability to optimize. And so sustainability became a non-functional requirement. So much about the history and the motivation. Next, I'd like to talk about the process, tools, and culture that we see at customers today who are successful in the area of optimizing for sustainability. Quick question here. What comes into your mind as a one-stop shop for evaluating architectures in the cloud? Something? Okay, so I mentioned it already. 10 years ago, the AWS Well-Architected Framework was launched. And it's a tool, it's a set of white papers, it's a red thread you will see in all tooling and in the console of AWS. It has the pillars for security, operational efficiency, reliability, performance, cost, and since 2 years ago, here at re:Invent, we launched sustainability as a sixth pillar. The framework provides a consistent approach to evaluate workloads in the cloud for customers and also for partners. Who knows the sustainability pillar and the white paper? 1, 2, 3, 4, 5, 6. Okay, so few of you. So most people come for the best practices. But I also want to draw the attention to the other important parts of it. So this is the outline of the well-architected sustainability pillar. And it also has the shared responsibility model as an important concept, design principles, the improvement process, the KPIs and metrics, where I will dive deeper into in a minute, and the relationship to other non-functional requirements, and finally, of course, the best practices. So starting with an important concept for this talk, this is the shared responsibility model. It means both AWS and customers do their share. AWS designs buildings, servers, data halls, etc., and takes care of it from the construction to the recycling. AWS purchases the energy and takes care that the energy and also other resources like water for cooling are used efficiently. And lastly, service teams run managed services and optimize them for resource efficiency and therefore sustainability. Customers, on top of that, are making architectural decisions. They select the services and they use the services. They determine which code is running and how efficient that code is. And you recognize here on this picture the colors from the shared responsibility model before. The message is, eventually all choices of AWS and customers lead to an impact, lead to an output. Customers use services efficiently, and AWS architects the services for efficiency. A bit less abstract, let's look at the input metric of customer service use and the output metrics of cost. Cost results from a simple economic model. Each service use has pricing terms, and depending on the use depends on the services which you are using, these pricing terms are applied, and then there's a cost. Emissions are a more complex calculation. Getting the emissions requires the measurement of the actual energy which is used, understanding what resources are used in this process to run a service. The customer carbon footprint tool provides the output of Scope 1 and Scope 2 emissions associated with your complete AWS usage. It is available, or you can look with the customer carbon footprint tool on 2 different levels. If you're logged into a payer account, you see the emissions associated with the whole AWS organization. And if you're logged into a standalone account, a linked account, then you see it on the scope of this single account. You can download a CSV file to analyze the data also in other tools. and the data is reported 3 years on a monthly granularity, 3 years back in time. And you can forecast also changes as Amazon stays on a path to 100% renewable energy use, and also depending on your service usage. And together and process all the data necessary for an accurate reporting, the tool has a lag of 3 months until a month is available in the tool for you to view. But a practice of continuous optimization cycles calls for more fine-grained and timely metrics. For this, you can complement the carbon emissions reported by the AWS Customer Carbon Footprint tool with input metrics that you can use as the proxy for the outputs, for the output of carbon emissions. Take the AWS cost and usage report, for example, to understand your service use. But also walk upstream in that process to understand the operational processes and also the business need that is fulfilled. And when I talk about the business need, the business metrics, so how many contracts, insurance contracts are issued, or how many connected vehicle miles do you serve? Having the proxy metrics of resource usage and also knowing my business metric, I can divide one by the other and have the ratio to calculate a sustainability key performance indicator. The idea of that, it is decoupled from the growth of your business. So when your business grows and your resource usage grows, the ratio will still be the same. But when then again the business the business demand is shrinking and you still reuse the same resources, that could be a cause for alarm. Dividing that ratio here is nothing new. You have seen this even in this talk before. It's what Werner called cost-aware architecture. And the difference is that it's not looking only at cost, but looking at resource usage, independent of any commercial instruments that are just discounts and have no direct impact on sustainability. To get started with this approach, I want to demo quickly the cloud intelligence dashboards. These dashboards are an open source framework which provide dashboards for cost, for understanding compute optimizer, for understanding your marketplace, performance and use. And we also have a dashboard here for sustainability metrics to get started. Let's switch to it in the browser. All right, so this is a public demo page which you can also open from your mobile or from your computer. It's having synthetic data about AWS organizations and accounts, so you can see the features of the dashboard. Each dashboard has multiple tabs. I switched here to the sustainability dashboard. Each of these dashboards has multiple tabs. And here in sustainability, in this Proxymetrics dashboard, each tab has here these two controls. First is the date range, so what range of the cost and usage reports do you want to visualize? Here the last 6 months, and what organization do you want to show? So which payer count is what you want to present. Let's see. For each of these tabs, you see the relevance to sustainability here in the text. That is coming from the well-architected pillar or from our web pages, so you can understand what this visual is displaying. Here, you see all regions on a map, and you see the distribution of your usage of AWS services distributed by the cost. So the different colors, what do they mean? When you paid close attention to the Amazon Sustainability Report for 2022, you've seen that 19 regions of AWS use electricity that is 100% attributable to renewable energy. And these are here presented in a light yellowish color. And then we have also the other regions in orange. So when you look at this, you should think, where do you expect your users to be? So this should be in some proximity, so you don't serve applications to your users by sending packages around the world, but also think about deploying new applications in regions where there are renewable energy projects by Amazon. Also on this page is development of this over time. And using renewable energy is good, but the greenest energy is the one we don't use. So that's why we're also looking at usage here with the compute proxies. This page here shows compute resources, the distribution of compute in the services of Amazon EC2, Fargate on ECS, Fargate on EKS, and Lambda. And what you can directly spot on this graph here is that the top account here is using, obviously, the most resources. And all accounts here use the orange color, which means EC2. So I have to scroll a bit and enlarge that scope a bit to see the first account here, which is also using Lambda and ECS. So think about the team here at the top using exclusively EC2. That means for the shared responsibility model, you are having the utilization of these instances and the patching with the latest and greatest patches for performance in your responsibility. And that is different for the team here below. So if I scroll down, I find the same bars, but colored differently by the instance families that are used in EC2. So I see, for example, at the top, they are using predominantly one instance family, that is the C5A. And this often indicates that the team probably fell in love with a certain instance family and just use it every time. But it's also an indicator that maybe they should use a different instance type to better suit the needs of the application, like picking, instead of a C instance, an R instance, a smaller R instance, or an M instance to right-size the instance. Second, these are mostly older generation types. With the RAG, you know that we already have an H generation, and here we have predominantly C5 and just a single R6 instance. And if the team moves to later instance types, to more modern hardware, that also brings more resource efficiency. And here at the bottom, you see in the dashboard also a development over time, how the resources were used, so that you can understand how this went better, or how there was an improvement, or when did we start using so many instances, for example. So the controls here are the same as in the previous page, but we also see these two controls here, grouping by linked account. That is here a control, and I can define also an environment tag. So I could also say, if I have a consistent tagging strategy, I could say I want to have my department code in the tag, which I want to use to group those bars instead of accounts. Also, you see this one here, which says include business KPI. And that is the concept which I shown before with the ratio of resource use divided by the business need. This one here is backed by a table that just has random data for business metrics. I show you how this works. So everything is in S3 and in Athena in this code. And I can look at the business metric table. And you see for each hour, you see the business metric, and these are accumulated, aggregated, and then joined to the cost and usage data to create those ratios, so that you understand how the business KPI has developed in this hour on an hourly granularity. You could fill that with your own data, like if you have an application, a certain workload, you could fill that in S3 and make this available to this dashboard. And then we have other storage proxies. Not only compute proxies, that show the same usage for EBS, for S3, and also data transfer, which is visible then in this tool. Good. Oops. Going back to the presentation. Yeah, check out this tool. Let us know feedback which you have in the GitHub project to get started with Proximetrics. And I want to quickly show examples by customers applying this concept of sustainability metrics. TUI is one of the world's largest leading global tourism platform companies, and in order to reach their sustainability goals, that's what I like about this quote here, every team must contribute. So also IT, of course. And therefore, they have been implementing this sustainability proximetrics and KPI approach to create visibility into the resources which they use for all application teams which they have. So the insights are then used in regular reviews and in optimization cycles, which then lead to an action. So an example for that is flight margin brain. This tool calculates 70 million fares daily, on a daily basis, on AWS. And with the sustainability KPI concept, the application teams gained visibility, identified some improvements, and, for example, reduced the caching layer compute resources by 40% with no impact on the customer experience for TUI. To achieve that, they have built dashboards like this here on the right. So the Proximetrics score is calculated and displayed on this dashboard, and the Proximetrics score is a sum of weighted resource usage combined into a single figure. That could be, for example, the number of nodes in a cluster, the vCPU hours, the utilization, etc., or the concurrent execution inside a Lambda function. And this approach of a weighted resource use also allows you to factor in multiple resources into a single figure, and also to incentivize certain resource usage over other, like using EC2 Spot, using managed services instead of self-managed services, etc. Here on the right side, the top graph, you see the nodes which this team here was using. And in the middle, you see the calls that run within the SLA that is defined. And on the bottom, you see how this influences each other. So first you see that at night, when the demand is lower by customers and the cache is not scaling in, you see that this Proximetric score gets worse. So the lower, the better. But the overall reduction of nodes in that caching cluster reduces that baseline into the green area which they defined as a goal. Second customer example is VMware. It's a provider of multi-cloud and virtualization services, and they are making use of sustainability KPIs to optimize for resource efficiency as well. So resource efficiency is also nothing new for them, as they already provide virtualization solutions for more than 2 decades. And in 2022, last year, they started different initiatives with AWS to drive sustainable software development, to understand how can our builders, how can our engineering teams build more sustainable software, and how can we support them here. So they started with incentivization, like gamification, like recognition of the teams who built the most sustainable designs. And they established also dedicated roles and committees to make sure that sustainability concerns are heard in the decision-making process. Through this process or this journey more, of establishing a sustainable culture, VMware has made a lot of learnings, and they are integrating this learning also into their tools to help the application teams which they have fast-track improvements. And they aligned their tooling with a well-architected pillar for sustainability, and integrated it also into their carbon measurement tooling. So they started with VMware Tanzu Cloud Health, and this was originally a FinOps platform, and now it gets the additional perspective of a green ops overview, not only showing application teams cost, but also indicators for resource efficiency through proxy metrics and KPIs. So the tool is currently in private beta, but once generally available, it can also be used by customers to identify opportunities to right-size, to identify opportunities to reduce the carbon emissions and receive recommendations. As you can see from the examples here with the dashboard from VMware and TUI, visibility is key. And if you have this visibility, you should rethink some common principles. For example, while it is important to have all the data for traceability and for researching why something was slow and how it can be improved, should you log everything forever? Second, should you back up the backup of the backup? And third, are faster responses all night and day for your users really addressing the main pain points if it's done at the expense of more resources that are needed for that? The pillars best practices provide a compilation of these questions and also others. It's like a checklist to go through your workload and all aspects of your application to improve. And each of these best practices provide a short description. It provides the anti-patterns that you probably tackle, that you have, so to identify these best practices. And it also links to implementation guides. So how can you get started, blogs, documents, etc. It is grouped in the topics of region selection, the alignment to demand, software and architecture, data, hardware and services, and process and culture. Optimizing always needs change, and sometimes you can do this change without affecting the customer experience and without breaking SLAs, as you have seen with TUI. If you optimize, you must know what this boundary is of your SLAs, and if you can maybe also move them to make trade-offs. That means you must know the SLA. So ask yourself, do you know the availability SLA of the workload which you build? It's not often the case, but if you know that, if you know the SLAs, you can identify and see if you overperform them. And if you overperform, that is also an indication for resource savings potential. Like, you could reduce the I/O and processing resources by approximating just the results. You could reduce the compute resources if you afford higher response times for your users. And you could reduce idle online capacity if your availability requirements can be relaxed. And while we don't know what the future holds for sustainability, we definitely know that to achieve these goals, which we have set in years and decades, we need to build on the past and present, and also need to accelerate. I want to focus on the role of innovation in this future, and what you can do as customers, and also where we as AWS are continuing to innovate. I said both AWS and customers do their share, and they contribute significantly and independently for more sustainable architectures, each in their silo. AWS is continuing to innovate for resource efficiency in the data centers, for example, the hardwares and the servers, and for which I want to highlight two topics here in the future. The first one, there is the future pretty close. Amazon is on a path to power all operations with 100% renewable energy by 2025. We achieved here, as you see also in the Amazon Sustainability Report, 90% across our business in 2022, and are continuing, of course, the investments. And in the demo what does it mean for AWS users? In the demo, I called out already 19 regions which use energy attributable 100% to renewable energies. And it's especially important that we invest, that AWS and Amazon invest into renewable energy projects in the grid, in the electricity grids, where it is heavily dependent on fossil fuels. So this year, we added 13 new renewable energy projects across the Asia-Pacific region, for example, in South Korea, India, and China. And we also introduced the first solar farm built on brownfield, that is land that has been abandoned due to industrial pollution. Second topic in the future is 2030. Sustainability is not only about decarbonization, but also about other resources like water. And last year, reInvent, we announced that we will be water positive by 2030. And with that, we will return more water to the communities in which we operate than we use in our direct operations. And since then, we already improved the metric of water usage efficiency from 0.25 liters per kilowatt hour to 0.19 liters of water per kilowatt hour. And the key here is increasing the sustainable water use from resources like recycled waters, the water reuse of cooling water, and supporting the projects that increase the water availability in communities around the world. And here, for example, in November, we announced 6 new water replenishment projects across Australia, India, Indonesia, Spain, and the US. And while AWS is continuing in the investments into resource efficiency of our data centers and services, we can do even better. We can do even better if you give us signals of what workloads you run, how flexible these workloads are, to indicate where we can make trade-offs. So by signaling you constraints and also maybe the information of what constraints can be relaxed, you can enable trade-offs for increased efficiency and service optimization. Depending on that can be as simple as picking a certain service or different feature over another. So you shift the responsibility to AWS to optimize for that and to make these trade-offs for resource efficiency. It's our goal to take as much responsibility as possible so you can focus on your business, on building for your business. Peter's keynote just on Monday was essentially a love song about all the serverless choices you have now for running databases and caches and data warehouses, while we take care about reducing the overhead that you have just for handling the peaks of your usage. Another example from the compute world, with a GlueFlex execution class, you can signal flexibility in terms of the varying priority and the time you have for executing your jobs. And that is translated by AWS Glue into using spare compute capacity instead of using dedicated hardware for your ETL pipelines. Who has already used M7i Flex instances? Anybody? Okay, you should. We introduced them in August, so not so bad that you don't know them yet, so or that you haven't used it yet. So similarly here, you can signal flexibility in compute capacity to allow us to make these trade-offs for resource efficiency, to increase the resource efficiency. And this is not the only, compute is not the only area where we can do that. You can also signal flexibility in storage. While AWS is making trade-offs for hardware and hardware efficiency and energy efficiency. Let's look at S3 Glacier Instant Retrieval. When we look at storage, hard drives remain still the best way to store data and to serve data that where you need to have the ability to access the data immediately. But while over the last decades, the size of the disks grew a lot, IOPS didn't. And this means that on a per terabyte basis, those disks even got slower. And when you, that does not help to scale the demand of a single storage tier. So you can imagine if it's getting slower, that is not a fit for a single storage tier. Either you have a very full but very idle hard drive, or you have very active drives that are underutilized from a storage perspective. And the solution here is that the disk shares, that a share of the disk can also be used for S3 Glacier instant retrieval that has less frequent access. And if you want to take a deeper look at that, it was already been told in 2021 by Peter DeSantis, so he goes in even greater detail in this keynote. And with these signals for demand of just taking another storage service, another storage feature, storage class, AWS can increase the resource efficiency and also, by the way, for those people who are convinced by US dollars, also reduce the cost of your workloads. Now, we covered the customer signals to enable trade-offs. And at the same time, you know your workload best and know how to optimize that. And don't get me wrong, we don't want to increase the responsibility on your side to optimize, but we want to offer more transparency, more tools, more selection, overall more convenience for you to make informed decisions and make it easier for you to optimize. If you think back to the topics of the well-architected pillar, most also have prescriptive tooling that continuously analyzes your usage and understands where's the potential for optimizations. They check typical improvements like Code Guru can identify expensive code that you can optimize. S3 Storage Lens can help you to identify cold storage buckets where you have barely accessed objects. Compute Optimizer, very important service, checks for underutilized EC2 instances, EBS volumes, or recommends then gives recommended instance type. It also gives you the insight into better Lambda configurations. And just in 2023, Compute Optimizer had over a dozen feature launches about new recommendations, new insights into your workloads. And last but not least, Cloud Intelligence dashboards also are a tool of that which you should use. There's also another tool which is called Sustainability Scanner. We launched it this year. It's an open source tool that checks your infrastructure against well-architected sustainability pillar best practices. And it does this at build time, so before you deploy your applications to production. And let's see how this works in practice. It's an open source tool that validates your CloudFormation templates against a customizable set of checks. It generates a report that calculates a sustainability score. And it also includes suggested improvements that you should apply or can apply to your templates. It's based on AWS CloudFormation Guard. That is a tool which is open source policy at code tool for evaluating CloudFormation templates. So it comes with a predefined set of rules, CloudWatch log retention, for example, and the use of energy-efficient configurations, instances, and Lambda functions. You can, of course, it's not a one-size-fits-all approach. So you can disable those rules if they are not a fit to your type of application. And you can extend also these tools to those which you found to be successful in your optimization journey. Let's see how this works in practice. Here's a CloudFormation template. It creates just a Lambda function in this code, in this infrastructure as code part, and a CloudWatch log group. I have installed Sustainability Scanner. I call it with the CloudFormation template, and the output follows an inverted scoring. So the scoring, the lower, the better, and it fails here 2 rules. One is that the lambda function architecture configuration is not ARM64, and the other one is not Graviton. And the second one is the CloudWatch log retention period that is by default indefinite, so storing everything forever. And while it is very beneficial to use this locally before you check in your code, in the distributed teams, it's even more important to run this as part of your build and deployment lifecycle. You can use this GitHub action. If you're using GitHub workflow, you can use this GitHub action to run it. You typically have a workflow file, and then you just need to define this action and also say in which step it should be executed. I've already set up here a new branch for that change into which I check in the code and push the code to. And as soon as this is pushed, it will be checked in GitHub. It looks like this. This is the merge request that has been created. There are checks included there, including the sustainability scanner, and it runs automatically here. And as soon as it runs, this is the red X here, it also shows the same result in a condensed way from this previous JSON output. The person who is then merging this or processing this merge request can accept it or can act in it or give it back to the committer, so things are fixed. I'm doing this here. I set the architecture for ARM64 and also the retention period for the lock group. Then I push the changes, and now the sustainability scanner is resulting with another comment, which takes a moment, and this is now 0. So it can inform the application of best practices for sustainability in your build and deployment process. There are lots of tools, and in the future we will have, of course, more tools, but I want to highlight 3 of them, which I've shown to give you also, to assign them to the corresponding use cases. So for example, if you want to report on the carbon emissions of your AWS total resources and want to see the history of that, then use the customer carbon footprint tool. If you want to quantify the input metrics and calculate a performance indicator, do this showback to your application teams, then use sustainability proxy metrics and KPIs. And if you want to just find out what should I improve, get recommendations, actionable recommendations of your application and your infrastructure, then make use of this tooling which I've shown on the page before on that overview. And what would be a talk about the future without Gen AI? Well, Gen AI has the potential to democratize AI for customers and everyone. We can also use it to tackle sustainability challenge, but we should ensure that we are minimizing the environmental impact. When it comes to the different options I'm showing here of using Gen AI, we also see customers using the full approach. So from starting with prompt engineering, using retrieval augmented generation, to fine-tuning, to training complete models. And these options here have an increasing use of energy profiles here. It's important to define or start with the right strategy and keep in mind the resource usage that you have. So start experimenting with the existing foundational models. Often prompt engineering will give you good results to get feedback from your customers about things. Use fine-tuning and RAG to achieve better results. And if required for the full training, use the efficient silicon like Trainium here. No matter what your workload is, also other workloads outside of AI, make sure you apply the well-architected best practices and do a well-architected review on that. And as the customer examples have shown, especially that one by that quote by TUI, it's important that everybody in the company fulfills their share, does contribute to resource efficiency, sustainability. Also, every team needs to be involved to achieve sustainability goals. So it's not only the how, but also the what. And think about where emission drivers are within your industry and how you can use technology to increase resource efficiency and tackle sustainability challenges. Almost all industries have common things like energy optimization, optimizing facility and building management, like carbon accounting, etc. And we have over 200, AWS has over 200 fully featured services to build solutions for that. And the AWS Solutions Library also already combines them in ready-to-use deployment, ready-to-use solutions and partner software and guidance, which you can use to get started quickly for your use case. Let's recap. I have 3 calls to action. One is start tracking and visualizing your progress. Establish a showback mechanism with application teams, for your application teams, so that they know how they are driving. Make it based on the customer carbon footprint tool. Also, sustainability proxy metrics and KPIs. If you want to optimize, start with directionally correct improvements. Review the best practices from the well-architected pillar. Use the recommendation tooling, of course. Focus on where you have the biggest opportunity to optimize. And last, use technology also to solve these data problems, to be more sustainable through the cloud, to not only optimize IT, but also all the things we have outside of IT that are also emitting carbon emissions. With that, we're at the end. We're a data-driven company. We're interested in your feedback so that we can improve those sessions here. If you have another minute of time, please use the app to rate this session. Other than that, have a nice replay today, and thank you for attending this session.